So now next speech, we have Jose Gomez from the Astrophysics Department of the Complutense University in Madrid is going to talk about the use of gvSIG to calculate the photo pollution thanks to satellite imaging.
Buenos días. Sí. Bueno, muchas gracias ante todo.
Good morning, and thank you to the organization for their invitation. I'm going to talk about the use of gvSIG to calculate the light pollution. So we are working at the Complutense University in Madrid. We are trying to reduce the lights because of the impact of that light on the energy consumption. We would save a lot of money, as you can imagine. Here you have the web where you can find lots of information on the NIX-NOx project. We have been working with the Astronomy Association, the University of Valencia, and other participants that are interested in that project. So first, I will talk about the light pollution and its definition from where we are extracting the data. You will see we have two different data: satellite imaging, spatial agency, and NASA. And from the ground, we are also using sensors, to get another array of data. So the objective is to develop a series of processes to analyze the images and data in order to have quality data to fight the light pollution, and then we will be able to determine the areas where we are not using correctly the energy and where we could do it differently. So you see here the light pollution is not only a problem for Spain, but for lots of other countries around the globe. So if you go to the URL that you see there, you can have a comparison between 1972 to 1999 all over the world, and you see the evolution of light pollution in the different areas. So you see, for example, here the sky glow. You see the lack of stars. You cannot see any of them, and it has been. This picture has been taken from the University Complutense in Madrid. And unfortunately, where you see that the energy is not well used there. What is what are the consequences? Well, we cannot see the stars, but there's more than that. It's not only a problem for the astronomers. We have used gvSIG to analyze the data that we get from the satellite and those that we are getting from the ground. So we have used the sextant extension too. So what are the data that we have used? I told you that we have been using satellite data from the Spatial Agency, from the DMSP NASA, and also data from AEMET and EUMETSAT. And before, those data were free, so you also have to check the evolution of open data from AEMET. Now, unfortunately, we don't have public access anymore to those data. And we have also vectorial data giving punctual information through sensors about the quality of the sky, and with luxometers, traditional luxometers. Here, for example, you have images from EUMETSAT. We have infrared imaging. Here we have some images from the special station, and the images that we can get from YouTube. You see the evolution of light around the globe overnight. So we have compared the images received by from NASA and non-calibrated images of the Earth's surface taken by the spatial station. So we have calibrated the image in order to have absolute values of the different flows, and then we have been able to treat those images. You know that the spatial station is traveling around the globe, so we need to have a time planning to know exactly when those images can and have to be taken when the spatial station is over the area that we want to study. And we have vectorial data that we can get through sensors. This one is the one that's very well known, the SQM measurement devices, giving us, well, the measure in magnitude per square arc second, and then we transform it into a data that we can manage. So we have equipped that device with a tripod in order to assess the quality of the sky in different positions. We have also equipped a car with that device in order to have a mobile unit, and with that new unit we can travel around the area, and we can do a mapping of the sky quality in different places, in different spots. We have also used azimuth measurement with a higher quality of the information that we are going to collect. We can, through a lens, we can get the sky glow. We have equipped, well, the roof of our university with such an equipment. We have one in Almeria, one in Doñana, and in other places in Spain to get, well, better equipment. So we can measure the sky glow and the energy that's dissipated from the ground, and that will remain floating in the sky. We have also used gvSIG to plan, well, the different routes that we have to follow using the road cartography and the measurements that we've been doing along those routes that we have designed. We have created a database so that any observer with its devices can introduce the measures taken. We have a Linux server for the publication of data. We can use Java or Python language, and the visualization is done through Google Map and also OpenStreetMap. When we are introducing or loading the data with the geographical position, the program will calculate the distance between the emitting course and the impact on the area. It calculates the province, the closest city, the number of inhabitants using the census. So, for example, we have a typical route. You see the routes that we have designed and drawn over the satellite image, and the measures that we have taken with the sensor. We have calibrated the data. It's a very simple architecture. We have used a PostGIS architecture for the publication of the geo server information. We get an information through a WMS service. We are using scripts Python to generate KML and shape so that they are easier to handle, and we are using gvSIG and Sextant extension for the spatial analysis. To compile, well, those data, well, we do it with different layers, where you see different colors, you see the different cities of Madrid region. We have different colors to make the difference between the darkest and the lightest areas, where we have the poorest quality or the best quality. And one of the things that we have also analyzed are the visibility basin. So from the central point that you see there, you know what is the horizon line, what is the visibility line, and we can determine if the cities have an impact on the surrounding areas. And you see, well, the route that we have followed for the monitoring, the control of the area. Here we see another chapter of this application. Any measurement can be geolocalized, and we get information about the closest cities and full information about their coordinates. It's very useful when we do some observation campaign to determine what are the darkest area and to know what is the impact of the light pollution from the cities to the surrounding areas. Here, where we see the evolution of light pollution from 1992 to 2010 around the globe, it's available without any problem to all. We have also designed a catalog for all the images that we were receiving, apart from the images that we are proposing. Well, our experts and people that are collaborating with our programs are also introducing their own images. So we are analyzing 100% of the photographies. We are deleting the photos that are taken during the day, and we only keep those that are taken at night in rural areas, and we are also defining and separating dark zones from the others that are that belongs to urban areas. We are using focal filters, geographical position filters, etc. From the satellite image, once calibrated, we put it on top of the cartography, and here you see the light produced by the street lights that we find around the airport of Madrid. We can also do a mosaic picture where to see the continuity of the map over the territory. From the ground images, we have those semi-spheres with the different quality of the sky. So you see a very dark area. Top left, we have a very dark area with almost no light pollution, and we have fairer, lighter areas where we see more pollution. It's not only a project designed by the Complutense University, but we're also working with the Spanish Astronomical Society and other universities. What are the results? Well, we have obtained the following ones. We have generated a series of themed maps with an algorithm to detect the areas that are suffering the most this kind of pollution. We have digital models with different elevation. We are not talking about height, but about light pollution. We have also generated some 3D maps. So we have theme map, as I told you. We are representing that quantity information that we have collected in order for any user to consult that data, and thanks to that data, thanks to that information, they can go to any public administration in order to request a lower impact on the area, on the surrounding area, so they can really use that information to request a lower contamination, lower pollution. So we can also detect that that area, like malls or city centers, that are responsible for this high light pollution. We have another application with open layers. On the left, you see the geo-reference image. If we zoom in on the lightest area with street view, we can find the street light that's polluting the most. We can really isolate every source. Here we have enlarged the airport area. We see the main motorways on the left. We have generating an isophotos map using the images that we have taken. Here you see the same area, the same airport area, and we have generating elevation maps. Well, you see this is the Fuenlabrada area near Madrid. We have some peaks representing a higher light, and if on top of that we put an auto picture where we see that we are generating a 3D photo of that land. You know that we can turn, we can incline the image, we can zoom in, zoom out, so we can see everything more in detail. So what do we want? Well, we would like to have a sky full of stars. If we have no noise at night, and we want to make sure that we have no noise to bother neighbors at night, we would also like to have the same with light, and we would like to control the electric consumption, because we know we could reduce cost studying the light pollution. And I would like to show you finally that using the 3G extension, a 3D extension from gvSIG, the image that I captured in Fuenlabrada, where you see that I can rotate the image. You see this elevation digital model with the orthophoto on top of it. And you see how the little peaks are appearing on that map. And when we get closer to one of them, we can identify the area, the street, or the source responsible for that peak. For any city, that description, that visual detection can be crisscrossed with the plots information, with the cadastral information, and we can find which building is responsible for that pollution, or maybe the parking of a mall, and we can see who's responsible for that too. So I would invite you to log in Nixnox page. You will get more information on light pollution. And it's not only the aesthetic aspect of light pollution, but also the economic aspect of light pollution that we have to take into account. Thank you very much.